Oh, the main concern is the sales with the cost.
I went over the assignment, right?
Mm.
With you guys, and I explained the markdown and all that?
In plain English.
No, you set us with a challenge.
Oh, you haven't gone through the assignment?
You said that you would release the ICA, but I
Okay, so
don't
that's
remember
where
you
we're
going
talking.
through the
Okay, so we're
ICA.
gonna start with that.
Yeah.
We're gonna do that and pointers to structs. That's it, because we only have 1 hour. And then we'll be in sync with the section that we had, okay? The section that we had yesterday,
Yes.
with the other section.
Yes. With the other section.
When? Or you're gonna stay in this one?
Depends.
Oh, okay.
You know, I remember you said like, you know, if you miss one section, you
Yeah,
always
that's
come
all
to
right.
the other one.
Yeah. So maybe the only day that it will be a bit more strict is the day when we have the exams.
Yes.
It's just because we are supposed to have the students that we're supposed to have the field.
I'll respect that decision.
But the rest we can count it.
Okay. I can't miss this day because I already missed it yesterday.
All right, so let's go over attendance. So then finally, I talked to Bo, she fixed that. Now everyone is in the section that's supposed to be. So now we're sections. So then we got, Amma Prince is here. Cheetan, not yet. Carl is here. Winston is here. Walpole. Omar is here, thank you. Arstid is here.
Just forcing myself. to-
Stephen is here. Darius.
Because we'll have to do it on the.
Joe John, yep.
Yeah, his laptop.
Sim Ranjit.
14 to 16.
Sim Ranjit, oh you? Rex is here, right? Caleb. I bet. Jacine, yes. Kritika, you. Rosie is here. Jean One, thank you, and Zoe. Joey.
So,
Sorry. I got messed up with your last name. I did pronounce a mix of the two. Okay. Okay, all right, so what notes?
Oh, so you choose the red because you always bad red.
Okay, so before we get started, are there any questions with the stuff that we covered before? Yeah?
Can we actually go through the solution from the challenge?
Oh, can we leave that for Monday?
We sure can.
Because then you guys can work on it over the weekend, maybe you get it done over the weekend. Me giving the answer doesn't help. You guys need to try to practice and get the answer.
You guys have a.
Well, it's just because we have only 1 hour, so I really want to.
get a lot of things.
Any
done.
other questions?
What are we doing today?
What we're doing today, we're releasing the assignment, so we're gonna talk about the assignment first.
Yes.
Okay? So then, if we don't cover everything else, this is fine, because I wanna give you guys the assignment. So. Oh, this is section 1. So how do you get to the assignment? You go here, and you should be able to see this here, okay? Well, if you don't see it, you can go to assessment, assignments, and then find it, and the assignment should have a link. Okay? You click on the link, and it takes you to the assignment on the website, but the assignment is not shown here now, they're hidden, so you just have to click the link from Brightspace, or remember what it is, okay? So, in this assignment, we're going to basically use this code that is here. You're gonna copy paste this code. And you're going to work on these sections, different sections, using a hash defined, like we explained in class. Okay? But then, for each part, you are supposed to answer all these questions. Okay? Part demo has 4 questions, part A has 7 questions, and so on. Part B 2 questions, plus 3 plus 2, whatever. So, how are we gonna do this? Let's just bring up the.
Maybe a demo to pull from.
Yeah, so you're going to open your repository maybe with VS Code. That's a good way to do it. Oops. And you're going to create inside your ICAs folder, you're going to create a subfolder with the name of the assignment. In this case, it's assignment 1, so I created an ICA 1. Okay? And you're going to put your code project in there. But aside from that, you're going to create a README file. I'm going to delete this one. So how you do this in VS Code? So you go inside the folder ICA1 and you just say new file and you call it readme.md. It has to be MD extension as in Markdown. Because we're going to do all our assignments in Markdown. Okay? So what is Markdown? Anybody familiar with it? It's like a standard for text files that can, just like HTML files, that they can easily render on GitHub pages. Okay. And they're very useful for documenting things and very easy to use. For example, the hashtag, the single hashtag is like your H1 in HTML. Okay, header 1. So it is going to be called assignment 1. Okay, and of course, you're going to have different parts to answer your questions, right? You're going to have -2, right? Part A, for example. And I can say dash question 1. Dot. And once you push this file, it will render properly on GitHub, but you can also preview it here with Shift, Control, and V as in Victor. It opens that, and that's how it renders. See, the dash is a bullet list, and you can have multiple lists here. And you could say things such as, I don't know, you could say, this is the answer, for example. Oops, I forgot that. And if you want to, let's say, make this text bolded, just do, you put it inside double stars. For example, that makes it bold. Okay. For example, oh, it's not even spelled properly. Okay. Now, these by itself, VS Code will render this, but if you want to have more nice stuff, there's a package that you can download. It's called Markdown. I'm not sure if it's gonna show up here properly. Yeah. Well, I'm not sure which one is the one I installed, to be honest. So I wouldn't ask you to do this yet.
Here or in your personal?
Huh?
Like when you downloaded the app, is it on your personal computer or is it?
No, here, like you can do this thing in yeah, no, I wouldn't worry about that. Like, I mean, it's, with this it will render properly. Yeah, so what we need to do. So, let's say I have this README done, and I want to push it to my site, right? Commit and push. And then I go repository view on GitHub, and my repo is here. If I go to my ICAs folder, my ICA1 subfolder is here, and it's got a README inside. See? And the advantage of having it named README is that it shows up here automatically, just like your index.html. So then you're going to have all your questions documented here. okay? As well as yours, obviously your source code when you develop something. So what you're gonna do, you're gonna copy this address, and you're gonna go to this assignment. I have to do it through, as a student. You as a learner, you click on this assignment, you go to the assignment. When you do your submission or in the comments, wherever you wanna do it, you paste the address, right? Or you can, if you wanna make it fancy, you can add a link, and you can name the link, okay, for example, assignment 1, and then you add, or I can't type today. And then you add the link here, and then you insert it like that, right? You can bullet it, whatever, right? I don't know how familiar you guys are with the submissions here on Brightspace, so it's just, yeah, you can do many things. You can insert videos, you can do Panopto videos. So whenever you, because I do, this part is like 50% of the grade. The other 50% is like, you have to do I have to do a checkup, okay? I'll talk about that later, but for this assignment in particular, since this is just exploration, there's actually no checkup. You just have to explore the thing yourself, and that's good enough for a full mark. When later on, if we cannot do checkoffs for everyone, sometimes students get behind and cannot get a live checkoff, you can always insert a video here, right? There's a way of inserting here. Panopto, it's not that one. Panopto student submission. And then when you go in here, you can upload a video that you record with your phone, or you can record a video here.
3.5 gigabyte upload limit. 3.5 gigabyte upload limit, just for everyone that knows.
Yeah, well.
If it's too high a quality, it'll just be
Yeah,
like,
yeah. You don't want to do like such a high super quality. Usually less than half a gig is fine. Yeah, so you can do that eventually but usually I get through everyone doing live checkoffs. Only a few students down the road need to upload videos. But just so you know, every assignment requires a checkoff component, except for this one, okay? Everything else is, because you have to, basically this is how it works. You submit your code, and then the other 50% is that you have to convince me that you wrote the code or you do understand what the code does. So you may just simply demonstrate to me, say a few things that, I've been doing this for a while, so it takes me only like 20 seconds to understand or to realize if you know what you wrote, the code there, or if the code came from someone else, or somebody, or something else. So I will know that right away. So yeah, so that's basically the checkoff part, okay? But for this one, it's
Do you want us to like explain the code and stuff, or just like help like when it's working on, like demo, like if I press this, or like
sometimes students are very proactive, and when they do the checkup, they just go and explain, hey, I did it this way. And when they're not proactive, then I start asking questions. Like for example, okay, in this part here, why do you do this like this? Or why does this line do? Not like random questions. A couple of questions, and that's good enough. Like I said, it doesn't take me that long.
So like a Java review.
Huh?
No, I'm joking.
Okay, so is everybody
So this
clear
is on the
about
resume.
what to do with the assignment for this one? Okay, so we're gonna do all the assignments in Markdown. So you're gonna thank me later on for this, because Markdown is nowadays a standard. In fact, all the pages that you see on my site, they're actually not HTML. They're done in Markdown. They're just rendered as HTML. But all this is Markdown files. Okay? So that, and you can even do diagrams. I think I showed you the mermaid diagrams once.
Oh, man.
Yeah, so see, for example, all these diagrams, well, this is a picture, but these ones are diagrams, and they are actually done in code. So that's actually a thing that is happening a lot nowadays, because one of the things that everybody hates doing as programmers is documentation. Right? So, but this thing, for example, for diagrams, that actually behind the scenes, that is code. And you can put that in GitHub, so you can version your documentation. See? So if something changes, you just change the code and it automatically generates it. But I can show you that later. Anyways, that's for the assignment. So assignment is there. You got the weekend to work on it and part of the next week. I put a referential like due date. Like I said, they're not hard due dates, but make sure you stay on track because this course starts ramping up like very quickly. Okay.
So, next week.
Yeah, that's the ideal target. Okay, so now what we have left to discuss, so you can do everything including this part, because the only part that you cannot do right now is this one, because we haven't really discussed, it's the last part. So, pointers. So far, we talked about the address, right? So we did display some of the addresses of variables that we declared, right? Remember, everything has an address, it's in memory, right? So we declare a variable and we can access the address of it with the ampersand. We put it up front of the variable and that gives us the address. Now, what is a pointer? Where a pointer is another variable that actually holds an address. So you could save now that address in a pointer.
Is it almost somewhat like an integer?
Sort of, but it's not really an integer because it has to be declared like this.
Oh, okay.
So for example, this, let's go through the objectives.
Okay.
The idea of this lesson is to understand what a pointer is and how it works in C. By no means I pretend explaining pointers in 25 minutes because that's a topic for several sessions, but we're just going to do a quick introduction and then we're going to revisit this concept eventually.
Thank you.
So pointers are used to manipulate variables, arrays, and data structs. You did study structs in 1300, right?
Yeah.
So any pointers apply pointers in the implementation of common data structs and recognize why pointers are essential in efficient data handling and peripheral access. Particularly in embedded systems, pointers are super relevant because everything has an address. So, okay, addresses are important. How do we declare a pointer? With a star. Okay, remember, the ampersand is just to get the address of the variable. The star is to declare the pointer. And the way it gets done, you specify the type, the star, and then the name you want to give to that pointer variable. So in particular, this one is a pointer to an integer variable, whereas this one is a pointer to a character variable. All right? Now, in this convention of how to do it, there are people that prefer to put the pointer next to the variable or next to the type. I think the majority likes it next to the variable name, whereas in my case I like it more like next to the type, but it doesn't matter. Either or works. Okay? It's up to you. One basic example here. We declare a simple variable x and we assign it 10. Remember, up to this point we did last time, right? Or a few classes ago. We were displaying the address of a variable. So that's no new. Now the only difference is that we're assigning that address into an address variable, which is the pointer. So this one is declared as a pointer to an integer, so it will hold the address of an integer, and that's why I'm assigning the address of this guy to here. Okay? Any questions so far? Maybe I'm going too fast. We have time. I don't know why I'm speaking so much. All right. So what happens if I declare a pointer? For example, if I do this. P number. What happens if I declare a pointer but I do not initialize it? What do you think happens?
It'll get angry at you.
No, actually it doesn't complain at all. Really, but at this point, after executing this line, what is the address that this guy contains?
It's not pointing to anything.
Yeah, so then what is that? How does the compiler handle something that is not initialized? Well, it depends on the compiler. Again, the answer is always it depends. C# normally, C# doesn't work really off the shelf with pointers, so therefore you don't have that problem. But in general, in C#, all variables are by default initialized to 0. In C, it's about the same depending where do you declare the variables, but for the pointer, it's not. And in C in general, when a variable is not declared and it's not clear what should be initialized to, it just picks a random address in memory or a random number. So having this pointer declared like this without initializing it actually could contain any address. So this is very dangerous. It's okay to have it declared like that. You just gotta make sure you initialize it to something before you use it. Because if you attempt to use it without being initialized, the pointer could be pointing to any address in memory, any.
So that's why it's dangerous?
Well, it's
Yeah, because it
inefficient.
could be something that you don't have access to, or a wrong memory location. Because remember, everything is mapped in here. Not only RAM memory, flash memory, peripherals, everything will be here. Everything has an address.
Gotcha.
Okay, so you might be trying to write to something that is invalid, that you don't have right access. And that's where the program crashes. And then you could say, well, you know what, just to make it simple like any other variable, I could initialize this to 0. That is also wrong, because 0 is a null pointer, so basically it points to the address 0. So that doesn't actually help either. So this is a good practice. Initialize to an address, the address of a variable right away. Then, the second example is where things start to get complicated, and that's something of the C language, unfortunately, that they use a star for two purposes. One purpose is for declaring the pointer, the other one is for dereferencing, and this one is something different than that. What this notation is saying, whatever P is pointing to, now give me the actual variable, the access of it, and then increment it by 5. So what this is in reality doing, it's incrementing the variable x by 5. But it's doing it through the pointer. Because the pointer is pointing to that address of that variable, and the star is what is called the dereferencing. The dereferencing, which is basically accessing the variable through the pointer.
Yeah.
Questions? Now, you may be thinking at this point, before I move any further, why do we do this? Like, why would you do this to increment the variable if you can just grab x and add 5? It's much simpler, right?
Less memory.
But here's the thing. Scope. What if the variable is declared in main, and then you want to use it in a function, and you want to change it inside that function? Can you do that?
Unless you set a global variable.
Unless you
No.
declare as global, you cannot, because the variable only belongs to the scope, okay? Now, how can you do that in C#? That is when you, I believe you briefly covered this, right? The ref,
No,
never,
we weren't allowed to use them,
but at least explain how it works.
I think.
Once.
Okay, so when you pass in, because when you're doing this, if you have a function, let's think that this is C#. If you have this function and you call it, well, I believe at this point it's evident what this function is doing, right? So if you call this function from main, and this function is defined somewhere else, outside main, what you're actually doing, you're just grabbing, when you call this one, well, this is a definition, right? But let's say in main somewhere you say, you call this function, right? You call it like that. And your x were defined somewhere before. For example, like that. So what this thing is doing, when it's calling that function that is defined somewhere, it's just taking the value of x and the value of I and passing it to this function. That's what's called a passing by value. So by no means, if you wanted to, for example, increment this variable inside this function, you cannot do that because this variable doesn't belong to the scope of this function. It belongs to a different scope. The only way you could do that is with a ref keyword. And the ref, what it does in C# is exactly what the pointer does here. The pointer, using this, instead of passing the variable x, you will pass the address of x. And then through the pointer dereference, you will be modifying it inside the function. That's one application of the pointers. Okay? Now, like Rex suggested, you could still, challenge this and say, well, you know what? I still don't like pointers. Why don't you just declare the variables all global, and then everybody has access to it? It's in the global scope. Any function can access it. Why not doing that? Is declaring variables as global a good practice?
Could assume no.
Generally, no. Like any experienced software developer would say no. However, in embedded systems is one of the few environments where sometimes you have to declare variables in the global scope, especially when they are changed inside interrupts. But obviously we haven't discussed that yet. But in general in C# or any other environment, there should be no reason for declaring global variables. Everything should have a scope. And if you want to change things outside that scope, you would use a reference, okay? And why is that? Because simple. If you declare a variable number in the global scope, and then somebody else codes a function and decides to call a variable number, then which one of the two is going to use when inside the function? The local one or the global one?
Global.
Yeah, well, we don't know. It depends on the compiler.
So it depends.
Yeah, but that's going to create such an inconsistency, right? Which is why you don't want that.
I also assume it's due to resource management as well. If I can just point or reference a memory address, I don't have to take up an additional memory address.
Yeah, because also when you declare things on the global scope, they go into that's more like a computers architecture course that obviously goes beyond the scope of this course. But when you declare variables as global, they go in the heap, whereas the ones that are inside functions, they are in the stack memory.
We want to avoid the heap.
Yeah, so they just basically get easily disposed when the function exits, right? Whereas the other ones occupy memory. Anyways, clear up to this point? Since the pointer holds an address, I could also use some pointer arithmetic, which is also dangerous. Because what this does, it does not increment the content of the pointer, it increments the pointer itself. So basically, if it's pointing to address 2001, you suddenly make it point to address 2002.
And that doesn't change if you were to do star p++?
If you use, excellent question. If you don't use this, now it's a matter of what gets done first. Because if the ++ gets done first, then we have a problem. But if the star gets done first, we're just incrementing whatever is inside. So how do we solve that problem? There's one easy solution for this problem.
Plus equals 1.
If you add the brackets, then you're being clear that you first want to dereference the pointer, and then increment whatever it's inside. Okay? However, if you didn't want to use the brackets, how do you solve that problem? I think it's already here. This one, C operator precedence. You can search for that online. And every operator in C, and in C# as well, has a precedence, meaning that what gets done first. So it looks like the pre-increment and post-increments are very high priority. They are priority 1. And when they have the same priority, they go from left to right. Okay? And the star, please know that the star could serve two purposes, same as the ampersand. The star could serve the purpose of dereference, which is the one that we're interested in right now because we're studying pointers. But it could also be, oops, what happened? It could also be multiplication. So we have to make sure which one of the two we are referring to, depending on the operation and the syntax, right? Same thing for the ampersand. It could be the address of priority 2. But if we're looking at a bitwise AND, then it has priority 8, right? So it depends where you put the ampersand, what it means, right?
So it depends.
It always depends.
Gotcha.
Everything has an address, it always depends. At the end of this course, we should do like a board with all the quotes that are relevant to this case. Anyways, if I don't put the brackets, what gets done first? The plus plus. So this thing is gonna increment the pointer first, and then the reference. But you know what? It may not, because this is a post increment. So I guess it's going to evaluate this
When it
one.
wants to read left to right as well, so.
Yeah. I guess it will be tricky, but
Maybe it doesn't, maybe it doesn't.
I wouldn't, like I said, we're just doing a quick introduction to this. We're not really digging too deep into it. I went off this thing. All right. So pointers can also be used with arrays. In case you didn't know, the name of the array is always a pointer to the first element of the array. So for example, that array there is declared as, its name as ARR, right?
Oh, it takes up index 0?
Yeah, so ARR is absolutely equivalent to the address of ARR at 0. It's exactly the same thing. Okay? Did you know that? No.
We do.
That explains why whenever you do C# again with reference, and if you try to pass in an array, you never pass in the array with a ref keyword, never, because arrays are always passed in by reference. So it actually doesn't make a copy of the array. You just pass in the address of the array, always in C#. And in C it's the same thing. So that means that if I wanted to get, for example, the content of array at 1, array at 1, this would be absolutely equivalent to do array plus 1, whatever that points to. Right? Because ARR points to the first element, and plus 1 an increment to the next element. But obviously, who wants to do that? That seems confusing. But what the point is here is that when we're using pointers on arrays, they are interchangeable. So you can use arrays with pointer notation and pointers with array notation, and it works the same way. Okay? We're going to revisit this with more detail later, because I just want to get to this part. Same thing for strings. A string type doesn't exist in C. Period. Doesn't. So the closest you can get is a pointer to a character. Okay? And in this case, it could be initialized like this, just because this is is taken as a constant pointer to character. Basically, you assign the string right away, and then you reutilize it. Otherwise, you will have to declare an array of characters. That's the only way you can call a string. And like I said in a show there, see, this could point to the second element of the array, which is E, just like I described it there. Structs. Structs are variables that custom type definitions. It's almost like the first approach to studying objects. I know you guys haven't studied objects yet, but the idea of a struct is to encapsulate multiple variables in one variable type that you define of your own, that you define a custom type. In this case, it's called person. And person can contain a name and an age inside. And the way you will access, see, the thing uses a pointer right away, but it never really explains how you access the struct. You access it with the dot operator, right? Which is why I created a demo here to at least explain a little bit of this. This is called structs. It's the last demo that we did. I hope it's pushed. So it's it's demo 8 struct.
Oh, yes.
Now, the way you have to declare this in C is a bit tricky. It's not as it's explained in the lesson there. I have to probably correct that. When you are declaring a data struct in C, you can declare it without the type def, and it will work. But the time is that every time you instantiate C, once you create this type person, you can say person is like int, like float. It's just a custom type that you just defined, and then you can have multiple person 1, 2, 3, whatever. Like you have multiple ints. However, the only way you can use it like this, as simple as this, is that you have to do a type definition. Otherwise, if you don't do type def, every time I do a new person, I have to do struct new person. And that's annoying. So the way you're going to ever declare a data struct, if you do it, which is unlikely to be done in this course. The reason why we're explaining you this is mostly so you can understand how the registers are defined inside structs. That's basically not for you to create structs. You do a type def keyword, which means that you are declaring a type, you're doing a type definition. You're declaring a custom type of a struct, and it's going to be named person. Now, why does it have to have a name here and here? It's just because the way C works. I'm sorry about that. So I like to put person underscore underscore so they're not the same, although they could be the same, but it could be misleading. So this is my actual type, and then I can instantiate that. As you can see, I can access the name by using the dot operator, which is the accessor. However, since this thing is an array of characters, I cannot just say person1.name equals my name, because it doesn't work like that, because it's not a string. String doesn't exist. So I tried to do Carlos, but I got bored like very quickly, and I only did 2 characters. So today I have a bit more energy, so I'll do 2 more. And it will become Carl. Carl? Yeah. Because I'm just lazy enough to keep going, right? And then, of course, I could be able to print this if I wanted to. You could do that when you're bored at home. But the thing is that we have 2 fields inside this struct. You could also define a pointer to a struct, and this is what's relevant for this course. I could say I want to define a pointer to person that is called person1, and I'm going to assign person1, sorry, and I'm going to assign the address of person1. So the same idea that I did before with the int, now I do with the struct. And the difference is when I declare a pointer to a struct, then instead of doing this, instead of doing what I have in comments here, which I could say whatever person1 is pointing to .h, and instead of doing that, that gets changed to this arrow operator. So, what does this arrow operator mean? It's just meaning that person1 is a pointer and is pointing to h. So it's actually accessing the internal field of this structure that's being pointed by this. So every time you see an arrow, it's basically that. Make sense? I know, I found these concepts like super quickly. I don't know why last class, yesterday without the section, I felt like I had a lot of time to explain this. Now I feel like I'm rushing a little bit. But the arrow is basically just to replace this. One quick thing that we can do to test this, see, and one step ahead. Once we start working with this micro, we're gonna have to, somebody already asked me that, we're gonna have to include the library for this particular micro that is on this board. This is coming next week. So spoilers, or only on WC2.1, sorry, whatever this class is.
218.
Yeah, so that library that I'm going to include here has the entire memory mapping for the micros with the addresses. And the library is the STM32 G0B1XX. And once I have this library, I have access to certain things in the library. I'm going to put here for testing only. And this is shown also in the notes, at the very end of the notes. For example, if I want to access this GPIO-A that we were referring to,
this GPIO-A obviously is somewhere in that memory mapping. And if I add the arrow operator, see, there's a bunch of things inside it. There's, for example, this register, there's this register, and that's why we're gonna start seeing this arrow a lot. So now if I'm curious about this, and I wanna look where this is defined, I can say GPIO-A, go to definition, and it happens that GPIO-A is a define that is a pointer to this type. See? And this type, what is it? Let's go to it. Oh, it's a data struct.
Oh.
That's a bunch of registers that are 32 bits each. We haven't yet discussed like the stdint library. Now, this thing, and with this I finish, has this weird identifier at the front that says __IO. And what is that?
Input output.
Well, we can try to go to definition. Oh, it happens that it's a macro, it's a define. It's defined somewhere in some other library. See, you can always navigate through things in this IDE. You can just right click and say go to definition. It will tell you exactly it's defined in this library. So __, remember this is a macro. I talked about this earlier when I even defined a function. Remember we defined? So basically all this is saying wherever you say underscore, wherever you see __, IO, it means volatile.
What? How do you say
Volatile.
RAM.
Volatile.
Yeah.
Read-write access to the memory.
Now, the obvious question is,
It depends.
no, what is the question after seeing this? What is the obvious question?
What is that?
What is what is that? What is volatile?
Yeah.
Give me an example that something that's volatile.
You can easily lose information.
Oh, I thought you said you. You are volatile. Sometimes I am. Sometimes I am.
Harsh,
Sometimes
right?
I'm in a good mood, sometimes I'm very bad.
That's a good example, right?
Yeah, but another example. Something that's volatile.
A volcano.
Yeah. What else? Stock market, right? Well, sometimes it's volatile, sometimes it's not. So, but it basically means that it can change at any point, right?
So
Why is this thing declared volatile? Why is the port declared volatile? And with this, I promise I finish. What did I say at the beginning? This is a memory mapping. Somewhere in here, I have my GPIO-A. My GPIO-A or whatever bit in here could be changed by the software by writing bitwise operators, right? Just writing one. But this is also connected to the hardware.
What happens when you turn it off?
Yeah, and the hardware could actually have a button that is connected to a one particular bit here, so it could change the value that's inside this port.
Gotcha.
So it could be changed by the hardware or by the software. And actually, that's my last quote here. So I'm accumulating the quotes here. Everything has an address. Bits can be changed by software or hardware. Okay? So that's why anything that can be changed by software or hardware has to be declared as volatile, so the compiler knows about it and takes supervision. I cannot explain more details about that, but that's it. Why? Why is that? Why the compiler needs to know that this is volatile?
Because the volatility.
Yeah, anything could happen, right?
Yeah.
So I gave the example yesterday. So the ones that were here yesterday, here a repeated joke. But I'm assuming that everybody lives with more people here, right? I live with more people. So one of the things I don't like in the morning is when everyone is going to the kitchen. I want to get my lunch from the fridge, which is why I try to get up 1 hour earlier. 5:30, I'm up. I'm downstairs packing my lunch, and then I go to take a shower after, so that I don't have to. Because if I want to open the fridge and somebody else wants to do the same, what happens? Share resources like collide, right? And it's a problem. That's exactly what could happen. All right, I'm done.
That's interesting, because RAM is also
Volatile.
volatile, because it's just, when you turn the machine off completely,
It wipes. Yeah, that's why it's also called volatile. And non-volatile is because it stays, right? Like the flash.
solid state, hard drives.
Oh, the repo you mean?